Hello and welcome to Chapter 5, Section 5.1, where we're going to learn a bit about what are called stereoisomers and also just isomers in general. So if you remember from um, our last sections, this is section both, I think it's Chapter 1 as well as in our last Chapter 4, we learned about two different kinds of isomers. That is, molecules that have the same parts, such as atoms, but have those atoms arranged in a different way, either through different connectivity, meaning the atoms are bonded to each other differently, or in a different spatial arrangement, that is the type of way the atoms are located in 3D space. Now, the first type of isomer that we learned about, if you remember, we had some good examples, but here's one where we were talking about. Let's see, we have a CH3, CH3. There we are. This is an example of one. This isn't an exact example that we already talked about, but we had something like this versus. And we said before that, let's see, this is C12, H367, N, and this one is C2, H247, N. And we said molecules that had the same molecular formula, but different ways of connecting the atoms in that molecular formula were called constitutional isomers. Exactly what we have here. Same molecular formula, different way of connecting those atoms. And the last section, or last chapter, we actually learned about a different type of isomerism, one that was based on those Hayworth projections, right? So here's our Hayworth projection, where it's way big and showing us the cyclohexane ring. And then we had things going up or things going down. And if we had H's on one side, something else on the other side versus the other way, there we go, versus having a mix like this where they're on opposite sides. The one where the chlorines here are on the same side, we were calling a cis molecule, and the one where they were on opposite sides, we were calling a trans molecule, if you remember. And this type of isomerism was different than the constitutional isomers because in this, the connectivity between atoms is the same, but how the atoms are rearranged in 3D space are different. And we called those stereoisomers, molecules with the same formula and connectivity, such as is here, because the formula, as you see, is C12345 H 2, 4, 6, 8, 9, 10, and Cl2. And in the other one, it is C12345 H 2, 4, 6, 8, 9, 10, Cl2. So the same formula, the same ways that the atoms are connected to each other, because this chloride is bonded to that carbon, and this chloride is bonded to the same carbon, and same with the other one as well. But they have different spatial arrangements. There are some that are going both down, like in the cis, and one that is going one up and one down in the trans. So these are the types of isomers that we are currently familiar with, but this will not be the only type of isomers that we remain familiar with. There will be some more, And mainly what we're going to do is add more types of stereoisomers that we are familiar with to this set of types of molecules. This has been section 5.1.